Guys, welcome to another lesson in the Science 10 chemistry unit. Today we're going to talk about the properties of ionic compounds. Now there are four main sort of characteristics of ionic compounds. The first one is that they have a high melting point, and so we're always going to go back to NaCl or table salt when I kind of talk about these examples right now. And we might be able to see if we can get down to the fab shop the high melting point of table salt. It takes a lot of heat for it to break down. Retention of crystal shape is another property. So you grind table salt down, it's still going to be crystallized. Soluble in water, so you put table salt in a cup of water, mix it around, not there anymore. And the conductivity in a solution. So if you have an ionic compound in a solution, so in water, it's going to conduct electricity even a little better. Now to the high melting point. So all ionic compounds are solid at room temperature because of their high melting point. And the attractions between the cations and the anions in a solid ionic compound are so strong that the ions are held in tight, highly organized crystal lattice. So they're not going to be liquid, they're not going to be gas, they're in that solid state in a tightly packed, kind of condensed crystal lattice. Now in the lattice, all the positive ions are surrounded by negative ions and vice versa. So all the negatives are surrounded by positive surrounded by negative. And a large amount of energy must be added in the form of heat before the ions can begin to move past each other in a liquid state. So you need to have a pile of heat going at this ionic compound in order to get it into liquid. So example, again, table salt. So each salt crystal is made up of a relatively flat surfaces, even upon it being grinded up. So you can grind it up as much as you want, still going to look like a crystal under a microscope. This results from the alternating positive and negative alignments of the ions of the crystal. Now when the crystal is hit, positive ions line up with each other and negative ions line up with each other. And the two flat crystals fly apart, producing a new perfectly flat surfaces. So it's just like two magnets. You can't really line up two magnets perfectly together. They repel one another. And same instance here, if you hit the crystal shape and it moves the positives slightly in front of the positives, well, they're going to repel each other, and that's what's going to split it up. But you're still going to get that crystal shape within the structure. You're just going to have two pieces now. So if we look here, let's get the pen out. So go back. So if we talk about retaining the crystal shape, so I have a block here of some sort of ionic compound. I have positive, negative, positive, negative, positive. So negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, and vice versa, all the way down. So anyways, I have a hammer here. So let's see. And I hit this crystal lattice, so go that way. And so what's going to happen is, so if we hit it roughly right around here somewhere, well, that's going to shove this bottom part of my crystal lattice this way. So what's going to happen? Well, I'll use a different color here. This negative is going to slightly, oh, that's not a different color, oh well. It's going to line up slightly with this negative. This positive slightly going to line up with this positive. The negative with this positive. And you can see how the pattern goes all the way through. Well, anyways, what that's going to do is going to have positive with positive, negative with negative, and that's going to cause then a split of the two pieces. Still, though, as we talked about, we'll be keeping their crystal structure. So, solubility in water. Now, all ionic compounds dissolve in water to some extent because both the cations and the anions are strongly attracted to water molecules. And this occurs because each water molecule is polar, so meaning that one end of the molecule has a slightly positive charge and the other end has a slightly negative charge. Now, when an ionic crystal is placed in water, some of the ions on the surface of the undissolved crystal are attracted into the water. And there they become surrounded by many water molecules. So we can see here the solubility of an ionic compound. Again, table salt in water. We have the positive. Let's just get back to the pen here. Oh. We have the positive sodium molecule, or sodium ion, attracted, or with the negative chloride ion. And so we can see the polarity of the water molecule, where we have positive end of the water molecule and the negative end of the water molecule, and so how that's attracted to the either the positive sodium ion or the negatively charged chloride ion. Now, solutions containing ionic compounds are good conductors of electricity. So this means the greater the concentration, and you can see by concentration there I have a little square brackets within rounded brackets. Well, if you see two square brackets together, that is a symbol for concentration. So the greater the concentration of ions in a solution, the more conductive the solution is. And solutions of ionic compounds are considered to be excellent electrolytes. An electrolyte is any solution that can conduct electricity. So if a solution does not contain ions, it will not really conduct. So example, would Na conduct electricity? So Na just being the atom form of sodium. And the answer here probably is not really. You don't really have that sort, you don't have that electrolyte, you don't have that ion, that electrical charge there to conduct electricity. Now would Na positive conduct electricity? Yes, it would. Now some molecular compounds such as HCl, which is hydrochloric acid, become ionic in solution. And hydrogen chloride reacts with water to produce new ions. And this is the general characteristics of some of the acids that we will study. Now, some ionic compounds dissolve better than others, and a substance that dissolves well is considered to be very soluble. Its chemical formula would be described by the subscript AQ when in solution, and a substance that does not dissolve well is considered slightly soluble and is followed by the subscript S. Now, with ionic compounds, there is a solubility table. And if we look right here, is our solubility table of some of the common ionic compounds. Now we can see anything from group 1, anything that has NH4, HO3, it is soluble, it's very soluble, meaning anything with these components would be very soluble, so it would break down in water. You can see here, example, CH3COO, which is acetate. It is most of the time very soluble with any other ion. However, combined with Ag or mercury, so silver or mercury, which is Hd, you are not going to get a soluble. You're not going to get a soluble compound. So it's going to be slightly soluble, meaning it's probably going to remain solid within that solution. And that's kind of how you read the solubility table here of ionic compounds in water. And that's it for our lesson today. So I hope you learned some about the properties of ionic compounds. Next lesson will deal with properties of molecular.